Hello.
Oh, it is recording. I see the little figure. Okay, great. I will do my little spiel and then I'll introduce you. Nice. Okay, here I go.
So, hi, I'm Sue and I'm from the Salvesen Mindroom Research Centre at the University of Edinburgh. We wanted to do something for all the practitioners and parents and students who are stuck at home but who still want to be developing their knowledge even during the lockdown. With lots of folk homeschooling and our usual family routines disrupted, it feels like developmental psychology is a good topic right now, and I'm a developmental psychologist. So what we're doing is short phone calls with psychologists who study learning and development in children and young people, and this is the first one. So today's PsychologiCALL is with Vic Simms from Ulster University, and she's going to talk to me about a paper with the title Understanding Number Line Estimation in Williams Syndrome and Down Syndrome. Hello, Vic.
Hello. I'm great, thank you. Yes, greetings from a very strangely sunny Belfast.
Oh, lovely. Yeah, we've got sunny weather in Edinburgh too, so that's good. So tell me, what was it that you discovered when you were doing this bit of research that we're talking about today?
So I suppose I have been obsessed with mathematical development for quite a long time. And my first postdoctoral position in 2008 looked at a task called the number line estimation task. It's a really simple task to think about. So just imagine right now, Sue, I'm asking you to think about the numbers from 0 to 100. Mm-hmm. And you're probably thinking that they go from left to right. And with the big numbers on the right-hand side and the little numbers on the left-hand side. And what's been really interesting about loads of research that we've done as a group and also other people across the world is that kids' performance on being able to position numbers on that number line, so estimate where numbers go on that number line, seems to be related to their mathematical ability. And one of the things that people thought about was this is like a kind of like a direct lens into how people represented number in their minds. So using this task was like an instant snapshot of how people stored number in their brains. And we kind of thought that it couldn't be that simple because when we're asking people to estimate the position on a number line, they're having to make a physical mark on a number line. They're having to do proportional thinking, all of these types of things. So we were really fascinated by some of the research that was coming out that suggested that the relationship between number line estimation and mathematical ability might be mediated or might be confounded by some other skills, such as visuospatial processing. And that's where a little grant opportunity came my way with Jo van Herwergen and the late, great Annette Carmelo-Smith, because we knew that individuals with Williams syndrome typically have quite poor visuospatial processing skills. And we thought we could ask quite a theoretically grounded question about their performance on a number line estimation task. So that was kind of the motivation for doing this study, to understand, are there very kind of general cognitive skills that might impact people's performance to do number line estimation, and is that related to mathematical abilities? And then at the same time, we were able to look at a group of individuals with Down syndrome, and we know that individuals with Down syndrome have relatively good visuospatial skills, but might have a little bit more problems with kind of fluency, verbal fluency. So it was a really interesting comparison study to do for a theoretical psychologist. A developmental psychologist is really interested in theory, but also in a practical sense as well.
Okay, so if I've understood correctly, then you're trying to kind of separate out with this task what part of it is about how good you are at maths, and what part of it is about how good you are at more general visuospatial things like picturing things in your head, estimating kind of sizes and lengths of things. Is that right?
Absolutely, yes. So we have we can have a really interesting, very clearly hypothesis-driven study that says, well, actually, if individuals who have poor visual spatial skills, so being able to, a typical task of visual spatial processing might be a design copying, so asking children, young people, adults to copy some pictures. That kind of helps us understand their visual spatial processing. We might be able to parse that out of their performance. So can we work out in number line estimation how much is important? How important is visuospatial processing? How important is it with your familiarity with just numbers? Your ability to count forwards and backwards. So we can start to really understand what that task is measuring, but we also might understand how we could help people improve their performance in some mathematical tasks. And I think the really exciting thing about the paper that we published, I suppose it was the end of last year, is that actually the comparative or the relative strengths of individuals with Williams syndrome, so their fluency with numbers, is the thing that predicts their performance on the number line estimation task. And individuals with Down syndrome, their relative strength with visuospatial skills predicts their performance on the number line estimation task. So the strengths that these individuals have predicts their performance on a task that we know is really highly related to general maths abilities. So I think it's a really positive and exciting story to be able to tell from a piece of research.
Oh, that's so nice. So different groups of children are drawing on different kinds of strengths to achieve the same task.
Absolutely. And I think that that's a really important and a positive message to be able to take from some of the research that maybe parents and practitioners here these are difficulties, but we're saying actually relative strengths are the things that we can maybe tap into to aid performance. And that kind of is also something that we like to think about as well. And we, in some of our research with people like Camilla Gilmore and Sam Johnson, have been looking a lot at children who are born very preterm. And again, we kind of try and think about, well, what are the relative strengths that these children might have, or how can we change the environment around them to help support their achievement or their performance in certain types of tasks. So taking a slightly different spin on things and trying to think about the more positive aspects to support learning rather than always thinking about the difficulties.
That's lovely. So before we get on to thinking a little bit more about what we can learn from it, can you just tell me a bit about how you did the study? Did you sit down face-to-face with these children and young people? Did they have a number line in front of them, or was it like a computer task? Tell me.
So this is part of a study funded by the British Academy. These are quite small grants, but they get a lot of bang for their buck, I think, out of these projects. So we had a really lovely researcher, Erica Ronzado, who worked on the project, and she did one-to-one assessments with individuals who have Williams syndrome, Down syndrome, and then a very broad range of age groups of children and adults, so that we could have comparison groups. The assessments were one-to-one, and one of the tasks that they did was the number line estimation task, and that was done just on paper and pencil. We have this task now on an iPad. That's okay, but sometimes there can be measurement issues because we can't get the precision of a lovely finely drawn pencil mark on a page, where when we're using the iPad it can be a bit messier. So we used a paper and pencil task for this study. But the young people, children and adults, did a number of other tasks that I think someone else might speak to about at another time during your little chat.
I think they might. That's right. Yeah. And so you're asking them to mark on the line according to a number that you've given them, and then you're literally just measuring how accurately they manage to do that?
Yes. So what we do is this is bringing developmental psychology right down to the first principles, where we use a lot of paper and give individuals blank number lines, and we ask them to position the number that we ask them on the number line. And each number has a separate number line, so you can't use your last estimation to help predict your next estimation. And that's really important because we want people to think about each number as a novel entity. Then what you have to do as a research assistant, I had to do this on a longitudinal study with maybe about 500 participants effectively. You measure the distance from the 0 point to where that estimation is, and then we can work out how accurate the person's estimation is in comparison to where the actual position of the number is. There's quite a lot of calculations involved, but it means that we can do some nice, quite simple statistical analysis to work out the amount of error in estimation, and also how spread out the numbers are across the number line. And what we typically see is children show a profile where they spread the small numbers out very, very, very large spaces between them, and then they squash all the big numbers together at the very end. So we would describe that as a logarithmic distribution. And what you see with development is that they become a nice linear distribution. So individuals become better at being able to space those numbers across the line evenly with age and development.
Mm. And you obviously wanted to capture visuospatial skills as well, given your hypothesis. So
yes.
Can you maybe just give me an example of one thing you used to measure that?
Yes. So in this study, we just used a very well-known kind of block design task. So people are given some images and they have to try and recreate the images with the manipulatives or the little blocks that they're given. So we have used a variety of different visuospatial tasks in a number of different studies when we've been looking at mathematics. This seems to be a good task that seems to relate quite highly with mathematical skills. So being able to think about an image and recreate it nearly in your mental space, and then be able to produce something at the end is a good way to measure those visuospatial skills. But we totally recognise there are multiple ways to be able to assess visuospatial skills. It's a really complex area of research, and lots of people, that is their sole focus, is looking at visuospatial processing. I suppose as someone who's interested in mathematical cognition, we look for the tasks that we see that perform well, and we choose out of the battery of tasks in terms of what we would want to be able to assess.
So in terms of what we can learn from this, right? So I love this idea that what you're drawing out is that these children are, I guess, relatively instinctively leaning on the things that they do well to help them in a task.
Yes.
Are there ways that maybe as parents or teachers we can encourage that? Is that something that you would say would be a recommendation from the work?
Yeah, so I think one of the important things about mathematical development is it's highly impacted by our emotions and our affects. And we know this from multiple other studies where we know that anxiety, and there's a specific type of anxiety called mathematical anxiety, can have a really serious impact on how we perform with numbers. And so I think that being able to reassure children or young people that they're trying very hard and they're doing as well as they possibly can is one thing that it kind of comes from that we're encouraging people to use the strengths and the approach that they find is successful for them. We know that children who are flexible and in the strategies that they use in mathematics, so you approach even a simple addition problem, there's always multiple ways that you can do that. Children who show that flexible approach to being able to solve a problem are generally better at much more complex mathematics. And that, again, may tell us something about being able to rely on your strengths because you know how to solve the problem and you're able to adapt the strategies that you use to solve that problem. So I think from this piece of research specifically around Williams syndrome and Down syndrome individuals, and they're doing this number line task, I think that the key message for us was that reliance on these kind of relative strengths is really important. But also, I think really reassuringly from this paper, there's two things I think I really am quite delighted by. One is that we were able to replicate a paper that had been done by a group, an Italian group, a number of years ago that suggested when you use a developmentally appropriate measure, individuals with Down syndrome were performing pretty much the same as their mental age group peers. And I think that's important because you don't really see loads of replication papers in this area of research. And I think that is the first thing that I'm really, really delighted that we were able to replicate a finding. I think that's really important. Shows scientific rigor. But the second thing, I suppose, as well, is that there had been an idea that individuals with Williams syndrome were actually performing significantly poorer than their mental age matched peers on this number line estimation task. And that had been using a number line that was really large, a 0 to 1,000 number line, which is kind of outside of the familiarity bracket of individuals with Williams syndrome. But when we drop down and use a number line that's developmentally appropriate, we see that that this group of individuals are performing similarly to their mental age matched peers. And I think that is also really important, that we can see that maybe mathematics, this number line task, is not something of a specific difficulty for individuals with Williams syndrome. So there are two, I think, important points that come from this paper. And also then more broadly for myself, who I'm just interested in the number line estimation task. And does this have like a kind of, are we able to look directly into the mind's eye through this task? And I think this piece of research says, no, absolutely not. because you're relying on so many other different skills to be able to do this task. I think for me, it was a paper that I feel really proud to have contributed to, because it's answering practical questions, but also broader methodological and theoretical questions.
Yeah, I think that's such a strength of the study, actually, and I really agree. It's so nice when you hit that sweet spot where you've got something interesting to say about the theory as well as about the kind of real life experience. Yeah,
and I think, as developmental psychologists, we are motivated by multiple things, aren't we? And I think, I'm a theoretical scientist at heart, but I really want my work to have practical application, because I think that's really, really important. And I don't think I've necessarily had a paper where I feel I've been able to pull those two things together so neatly as in this paper. So it's been really fulfilling. And the other thing is, I think, Annette Carmel-Smith unfortunately passed away, at the beginning actually of this project, and she had quite huge questions to ask around, cross syndrome comparisons and mathematics skills, and she obviously talked about much more broader issues than mathematics. But I think it was really lovely to be able to test some of the questions that she had been asking, and be able to kind of carry on with that type of work. So I feel really privileged to have been part of this research team.
Yeah, absolutely. And to anyone listening who's kind of interested in psychology, then the writings of Annette Carmel-Smith are just so highly.
Yeah, absolutely. Her beautiful papers around neuroconstructivism and, her really broad theoretical contributions, but then as well, her kind of real insight and passion for families with children who may have developmental disorders, or more broadly. And I just think what an amazing person and what an amazing contribution to developmental psychology in the UK and internationally.
Yeah, absolutely. So just one final question then, thinking about any early career researchers or students who might be listening, is there anything that you want to say to them in this trying time? Any words of wisdom?
That's a big ask. So, I think, look, early career researchers, so I was a postdoc for 6 years. And it was a frustrating time because you were always on the lookout for the next post, and it can be quite difficult. My husband and I commuted between Scotland and Northern Ireland and things like that. But the time that I had to read and think is something that I know I will never get back. And I know that times at this moment in time are hectic and crazy, but we have got a slightly enforced slowing down. The pace of research has to slow down, especially if we're developmental psychologists. I'm thinking we could be opportunistic and try and do lots of research, doing, assessing children through Zoom and things like that. But how real are these measures that we're taking during a time where we've got huge amounts of parental stress, kids are not seeing their friends, all of these things we have to put in context. So I think having that little bit of time to sit and think is really important. And I think that actually, this paper for me has taken has been 12 years in the making, because really this work started in 2008 when I first started my first postdoc, and I'm still doing this type of work now. And I think that shows us that sometimes our thoughts have to distill, and that trying to take some time to reflect on what we're doing research, why we're doing research, and what we are really, really interested in is really important, especially at the start of your career. I did a postdoc in the middle of my postdoc in an area of research that I haven't continued to publish in, but I learned unbelievable skills in terms of experimental psychology I worked with Teresa McCormack at Queen's University. Those times, I think, are times when we can really reflect on broader developmental issues. We can think about theory. We can think about how these things fit together in a system of development. And I think that this is really horrible for PhD students, and this is really horrible for early career researchers, because you feel like your project has had a massive brake pedal slammed down, but actually trying to think bigger thoughts, taking this opportunity, even if it's only like 20 minutes, because I recognize that there's, it's stressful and there's not loads of time to think, but trying to use this time as a period of reflection to think about how your work might fit into a bigger picture is probably a kind of something that we may not have the opportunity to do again once the brake pedal's off again and we fly back into our project. So maybe seeing this as a time to think a little bit deeper might be a good opportunity.
Perfect words of wisdom. Thank you.
No problem. I will try and do that myself, obviously.
Yeah, it's easier giving advice than taking it, isn't it?
Absolutely.
So I'm going to thank you now so much for giving me a bit of your time to do our first ever PsychologiCALL. And anyone who's listening, if you want to find out more about Vic's work and about what we talked about today, then there will be links on the podcast page at ed.ac.uk/Salvesen-research. So thank you so much, Vic. And
thank you for having me. Thanks. Bye.
Okay, we did it. I thought that went quite smoothly.